Okay, good morning, everyone. I'd like to kick off the next session and turn it over to Jordan Gonda from the region of Niagara region, rather. A great presentation here. There's a bunch of collaborators in the room. Their names are on the board there, but I'll turn it over. I think Jordan's plan is to sort of present for 30 minutes and then open up the floor to questions. Over to you, Jordan.
Yeah, thank you, Robert. Thanks, everyone. Thanks for dropping into my session. What I'm presenting on today is a project we've been working on for the last year. It's really looking at how we can better project and prioritize our capital works. The topic for today is a decision support tool that we developed. So I'll start off with just some background and relevance, who we are at Niagara Region, why this tool is important, and then I'll get more into the details, what we mean by a risk-based decision tool, what's in it, how that links to a 10-year financial forecast, and then I'd like to end off with a case study of how we used it this year, and then just some more thoughts going forward. So I've noticed that there's a lot of different industries here today. Not everyone works in the municipal world. We have some unique challenges. So what we are is an upper tier municipality. So if you look at that left panel here, we're situated in southern Ontario between Lake Ontario and Lake Erie. And what we are is that there's about 11 local area municipalities, cities like Niagara Falls, St. Catharines. What we do at the region is we supply and treat the drinking water to these cities and also treat the wastewater from them. So there's approximately almost 500,000 people that we serve. Because there's many cities that we serve, it's quite a large network. About $6 billion worth of assets, so worth of treatment plants, pumping stations, transmission mains, and this system's getting kind of old, so we have some pressures that we're dealing with. Right now we have about $1 billion worth of capital projects, so that doesn't include maintenance spending, operations. Those are just the large projects like pipeline rehabilitation, pumping station replacement, and these billion-dollar projects are ongoing, and that's because we have quite a large backlog that we're dealing with. So a lot of pressures that we don't quite have enough money to fund in the short term. We're trying to balance this with some long-term needs. We're a growing region. We're expecting to grow by about 50% over the next 20 years. So you can imagine there's some conflict of, do we spend money so we can service more housing, or do we spend money so that we can replace a 50-year-old treatment plant that is deteriorating quite rapidly? Our system, so it's a bit unusual. We have about 17 treatment plants. We don't just have one centralized system. So looking after 17 plants is quite a challenge. It's a lot of assets. We have almost 200 facilities. So those are pumping stations, water storage reservoirs, odor control facilities, and on top of that, 600 kilometers of mains. So for 500,000 people, that's quite a large network of infrastructure that all has its unique needs. In total, we treat 150 megaliters of water a day and 200 megaliters of wastewater. Okay, let's get into the challenge. I like this graphic here. It illustrates quite well what we're dealing with. What these lines are showing is our capital budget, so the capital expenditure going forward. The blue line is wastewater spending, the orange line is water spending, and this came from our budget book last year. What we do at a municipality is that we can plan long term, but we only get approved spending for the next year. So if we have multi-year projects, we can't lock in funding for 5 years or 10 years. And what this does is it creates some unrealistic expectations. So what we said last year is, okay, we got approved spending for, if you just look here, for about $50 million each for water and wastewater. We're going to spend this all in capital projects. These are a lot of critical needs. But then we said, oh, we have a huge backlog here. This line here is $300 million. So that's over 6 times what we spent last year. We're just saying that we're going to spend 6 times the money of what we spent the year before. This is a bit unrealistic. It's not good planning. What we want to do instead is flatten that curve. Some of these needs that we're saying we're doing in 2025, we might not do until 2030 or possibly even 2040 with the kind of funding we expect. And what it does to our operators and maintainers is we're saying to them, yeah, we can't do an overhaul of your treatment plant next year, but just wait 1 more year after that and we're going to fix everything. No need to accelerate your maintenance because it's all taken care of. But the risk we could have is that it might be 10 or 20 years before that plant is overhauled. And if they're not doing the maintenance to keep it up that long, we could deal with some pretty bad failures. So that's where we're changing things. We looked at our process that we've done in the previous years. It's pretty typical for municipalities. It's a bit ad hoc. So the way that the capital process has worked is that we get requests from various sources. It could be designs that are going into construction. It could be issues that are found from operators. A pump is not working. It could be engineering reports like master plans. We all kind of just put them together, have many meetings with project managers, and say, okay, now we have the list of 220 projects, and let's just look at what we're going to do next year. And then what we tell finance is that we have a huge need. We give them that entire list, and finance only approves the few at the top for next year. We see a lot of opportunities to improve our capital planning. Earlier this year, we took an exercise of doing a state of maturity assessment of our asset management processes, trying to align it more closely to the global landscape, the IAM. Our biggest gap was in our decision making. That's what we see here. So this is the IAM framework. And where we can make improvements is number one is that we can have a more structured approach for identifying capital projects. It's not just a wish list, but perhaps we can look at our maintenance records, we can look at our asset inventory, and be more strategic about it. Number two, we can use a risk-based approach to our capital planning. So it's not one long wish list, but it is a very sequential, targeted projects and having an understanding of what we're doing long term. This ultimately feeds into our overall strategy because now we have a long-term plan. Now we know what risks we have if we don't do work, and we can make a better case for changing our strategies like more maintenance or advocating for more funding. So the focus of today is kind of on that middle bullet point, is that risk-based model, is it's really quite an improvement for us. And where that fits in is we can go back to our capital planning process, and you see these yellow boxes are where we've made improvements now. So we are able to mine some of our asset data. We're able to meet with planning and development and understanding the realism to how growth is happening. But most importantly is that second blue box, that we have less meetings. We now start our capital planning process with a 10-year list, a 10-year forecast that we develop based on risk. And now the meetings are all about, if we take a project out, what goes back in? We can now look at different scenarios, looking at different amounts of funding. And now we can go to finance and say, okay, this is what we want to do. if we get less money, this is what we're doing instead, but this is what's chopped off, and these are the risks. So it's a much more intelligent way going forward. That model that we're starting off now for our capital planning process, it's essentially a value for money model. That's what return on investment is. So it's looking at, number one, the risks of projects. So that is, if we don't do a project, what's the probability we'll have a failure? And if we have a failure, how bad is it? What's the consequence? And that's through the lens of what's the impact on the people, the businesses, that's the social, on the economic, on the environmental. The amount of benefit we get from any product is the overall reduction in risk. So if we replace a pump that's very old, the benefit is that now we're not discharging wastewater to the environment, and we can quantify that. We can look at how much flow that is, what's the condition, and now we have a very real benefit that's a number. We also consider what we call growth projects alongside existing system. So now if we're in that kind of competition of do we fund projects so we can enable housing versus projects for fixing existing system, we can evaluate them side by side under the same kind of criteria. So we look at the whole return on investment of any project. What's the benefit to the existing side, and what's the benefit to having more housing and more growth in our communities? The first half of the equation is the probability of failure. We use a statistical approach to this, and you can really illustrate it here on the bottom right. You can think of when you buy a jug of milk, it has a best before date. We know that the day you reach that, you're not going to toss out the milk, but what we do know is maybe that's where you want to keep a careful eye, because at some point you're at an elevated risk of that milk kind of going bad. We think of the same way for our infrastructure. We have a useful life of a pump, say it's 30 or 40 years. It's not going to fail right at that time, but we can see that the probability curve becomes more steep. We do this through a Weibull calculation, and we're doing a lot of ongoing work now calibrating it through expert elicitation, looking at our maintenance logs. It's still kind of a work in progress, but it's a really good approach now that we have a statistical model for looking at the failure. We are able to integrate that with complex systems. So I'm sure many of you here that work in a kind of manufacturing or industry environment, you would have the same kind of challenge. It's very easy to calculate a probability of failure in one small asset like a motor, but it's difficult when you roll it up to a project, because a project could have many buildings. And what I'm showing here is that any building would have components like the site works, the structure, the architectural elements. And then we would have process elements that could run in parallel. We might have redundancies. We might have 3 or 4 pumps, and we keep one offline. So our probability of failure considers all of this. We look at a redundancy analysis, and that overall probability of failure of any given project is doing this kind of series versus parallel analysis. On the consequence side, it's quite simple. It's just looking at the triple bottom line. For any project, we look at kind of 3 factors. We look at the extent. If a pump fails, how many households can be affected by it? The duration, how long is it to fix? Is it hours, days, weeks? And then severity, will it lead to basement flooding? What are we talking about? So we capture these kind of 3 dimensions across the environmental impacts, social impacts. So social being, does it impact people's health? Will lack of water, just obviously people need that to live. Could it shut down businesses and we lose money? Does it affect our reputation? And then the last one is the financial. So if we don't do a capital project, do we incur more maintenance costs? Maybe it's we do the work because we see cost savings doing it early. A key feature is that it's data-driven. In the past, our risk models were generally more qualitative. I see this quite a bit where you give a score of 1 to 5 based on some interpretation of a written criteria. Instead, what we do is we actually hard code in some of these relationships. So I'm just showing one of many. If we're looking at a wastewater gravity sewer, what we can do is we would have the diameter of the pipe in the inventory. So for every sewer main project, we know the diameter. And based on a hydraulic flow curve, we can understand what kind of flow a diameter gives. And based on that flow, we understand how much of a contamination that is to a water body. So we're able to link the risk model to our asset register. We're able to look at all of the assets that make up a project and extract consequences of failure based on established relationships. That's kind of the summary of the risk model. So now I want to get more into why it's important and what we do with it. As a municipality and also as many of you here, everything comes down to providing a level of service. The level of service is just really the balance of cost, performance, and risk. So the level of service, the value that we provide in terms of performance is having a reliable system, being able to meet legislative requirements, and meeting growth. We look at balancing that with risk, having risk mitigation plans if we have budget shortfalls, if projects are deferred. And ultimately, we have a cost. So we have a finite funding source, we get money from reserves, and it's all linked to affordability. This is a balance, so you can imagine if we want to be more affordable to our residents, if we don't get approved funding, that would mean we have less performance and more risk. If we don't replace a pump proactively, we could have a sudden failure, we could have basement flooding. Those are all risks and lack of performance. So with our 10-year plan that we developed, now we can show this kind of balance. We can show a sequence of projects, and by knowing the risk of any project and knowing whether it's deferred, we have an idea of the kind of risks we're taking on. What this is showing here is these are all projects. So what we do is we take all the projects in our risk model. This is showing the amount of money they would cost in each year. And we compare that over time to our funding sources. So the orange band here is showing our reserve balance as a percentage of our asset value. We have targets to keep that around 1%. And then I'm also showing another funding source, our development charges that we get so that we can support new housing. In any given year, we can't have a negative balance. So what actually happens is that as we go over time, some projects get pushed out because we can't afford them. This number 8 here, we might have wanted it next year, but it might have to wait another 2 years because of affordability. Now what we can do is we've assessed all the risk. We can communicate, if we don't do this, we have risks. For these kind of projects, then we do a residual risk exercise. So for example, if we have a treatment plant upgrade that we want to do next year, it might cost $150 million. We get $40 million each year. It's impossible to do next year. With this kind of plan, we can slot it out 15 years, And we can start looking at mitigation actions. We can say, okay, well, maybe we dedicate $500,000 each year to enhanced maintenance on very critical components. And maybe we also dedicate some money towards a reserve. So now the improvement is that we are aware of our risks and we have a plan in place so that once we fund the project, when we predict we'll fund it, everything will be okay. Another kind of strategy we can take is if we have a less critical asset like a pumping station, we might rescope the project. We might look at it closer and think, okay, instead of replacing an entire pumping station, the building, the wet well, the pumps, the electrical, maybe it's only the pumps that are in poor condition that need replacement. And maybe we rescope it so it's more affordable and can be done sooner. Now I'm going to finish off with a case study. So this is a kind of a unique situation that came upon us this year. We had a large-scale economic development. So we had a battery plant moving into one of our communities. They required a lot of water for their processes. They also produced a lot of wastewater. And what that meant is that we had to upsize some of our infrastructure so that they can be serviced. This was a political priority. It was out of our hands. We didn't have senior government funding. We just had to make do. And what we saw is they're quite large projects. So for this example, we had a pumping station that was $23 million on the wastewater side, and a new water main upsizing that was $13 million. In our model, we ranked them, and we know we would have done these projects eventually, but it would have been a couple years out, not next year, because they're not the highest risk projects. We then had to compare them to our original plan, and what you see here in the red is that we have quite a number of projects that now have to be moved out. So we get 40 million next year, then 43, and so on. So half our funding is taken up just from this one project. So at least what we're able to do with our risk-based model is that we can at least fund the most important ones at the top, get the most value for money, and then look at what's pushed out. We look at every one of them, and we can look at this risk mitigation exercise. And what we generally find is for a lot of those projects, we're able to make do. We're able to prolong life through doing more maintenance. We're able to do bypassing if that would come up. We can do spot repairs. But what we found is that there's some projects that are very critical that we can't just do more maintenance. We have force mains that are deteriorated, and they're quite a risk if they burst. That's a lot of wastewater flow that would go into our channels, into our environment. So we communicate that we need to do these projects, and we've backed it up with our risk model, clearly illustrating the kinds of extents and durations of risks. And ultimately what we got is some more funding from senior government. So doing this kind of exercise allows us to secure more funding when we have to, and allows us to change our plans so we can adapt. I'm just going to close off with a few limitations. A risk model is just one of many decision support tools. A lot of people like to look at it as the source of truth. They like to model and say, hey, our model says these are the projects that we're doing over 10 years. We're not going to change. What happens in reality is that there's some deviations. There's some things that are very hard to model. And some of these factors are things like coordination. We have transportation department, we have road projects, we have water projects. It might mean bringing some priorities forward because we don't want to dig up a road that's just been replaced. We also coordinate with our local area municipalities. So these kind of coordinations are very hard to model. We also cannot model the political climate. We cannot predict when there'll be these kind of new changes, directives coming from senior government. So I like to think of the 80-20 rule. A risk model should work for 80% of your assets, but there is some wiggle room. So this kind of model is a starting point. It allows us to have good discussions. It allows us to look at our assumptions and make risk mitigation plans. Some of the benefits is that we now have realism to long-term investments. We no longer have that huge wave coming up in 1 year. Instead, now we have a very even look over 10 years. We have some discussions. Maybe we can't fund every design that we have for construction. Maybe some of those designs have to go on the shelf. It grounds discussions with project managers. Everyone says their project is the most critical, but what we can show is that, yes, yours is important, but we have many other projects that are just as or more important. Or what we might say is, okay, maybe we got your assumptions wrong. Maybe we should sit down and talk and reevaluate. We can look at the level of service into the future, so we can understand how the backlog will grow and shrink. We can understand what kind of risks we have by putting off key infrastructure projects. And I think the most important benefit here is that it links an asset management strategy to a financial plan. These are often separate exercises. A lot of municipalities would have an asset management plan, asset management strategy, but then the financing would be something on the side. What we're doing now is that we link them together, and we can start having good discussions about rescoping projects, different kinds of investment, setting up reserves. So they're all kind of good tools that we use. So yeah, thanks everyone, and I'd be happy to take any questions.
It's great. That's great. Any questions specifically around Jordan's presentation? It was a great presentation. I haven't seen a lot of municipalities in that last bullet point linking asset management with finance. And it sounds like this journey is starting to happen. So are there any municipalities here that are having any challenges with sort of their state of good repair and their growth, the DC conversation and the separation of those areas? And do you have any specific questions? Because it sounds like the Niagara region is on a really good track here and maybe in a bit of a leadership role. I haven't seen this before, where we're having risk-based conversations for our investment planning. So I don't know if there's any. I know there's some municipalities from St. John here and in Ontario. Do you have any questions? Yep. Oh, sorry. Someone's got their hand up. Sorry.
Thank you very much, Jordan. It was fantastic to see how you are connecting asset management with finance. One question I had was, what level are you doing this analysis on? I know at the beginning you mentioned various treatment plans and the asset centers. Like, did you consider breaking down all those high-level plant-wide line items into individual assets to see if you can squeeze in more budget to do high-risk, small projects at various sites? And a follow-on question in the same line is, if one of the projects could not be completely done because you don't have the budget, was there a second option just to sustain the risk instead of increasing the risk? Is that an option to balance out the allocation of the budget?
A great question. So the first part was, at what level do we do our analysis? Let me just go back here. So we We have an asset register that is multi-level hierarchy. What's here is in the middle, so these are looking at the major categories. But below this, we have functional systems like a pumping system. Below that, we would have the pump, and below that, there would be like the gearbox, the valves. For our risk analysis, we use asset level information, but we aggregate that up to a whole project level. So if it's a facility, we would have individual assets for the building structural, like the envelope, the roofing system. We have assets for the process piping and equipment. And through a redundancy analysis, we roll them up. So when we have assets in parallel, we look at what's kind of the weakest link, and that's the probability of failure. And if it's if it's in series, it's what's the weakest link, and if it's in parallel, like the end here, it's looking at what kind of buffer do we have. So, the second part was. Sorry, could you repeat the second part?
Second part was that, can you do a different, like a sustained risk mitigation instead of like a full-on project where you are replacing the whole system if it's prone to failure? Okay, can we increase the maintenance so we can incur a little bit cost but push out the risk 1 or 2 years down the road instead of taking the full risk right now? It's kind of like fallback situation instead of a complete replacement.
Yeah, actually, that's kind of a new initiative that we're starting. So we have these kinds of projects that we call sustainability programs. So we would have a water treatment plant program, a pumping station program, and what that is it's a bucket of money, a couple million, that we can spend on various sites. And we spend it on, generally, the intent now is to spend it on what we call major maintenance. So it is using capital dollars, but for very targeted replacements, like something like just an individual pump or an aeration tank. So we would transfer use our capital dollars, but really it's to do kind of that large maintenance work. And when we do these kinds of work, what we might find is that some of our big capital projects we might push out a couple of years, or we might not do because those kind of targeted maintenance does all that we need.
Great. Another question over here.
My name's April, and I'm with Halifax Water. So we have a lot of the same problems that you had before you started this new process, planning 10 years out. So we haven't gone to the risk-based model, but I'm wondering, there always has to be a lot of alignment to get any change in our organization. And I'm wondering who specifically or what group really pushed for the change to risk-based?
Yeah, thank you. The change for the risk-based came from our group. We're within the water and wastewater division. We have an asset management section. So those are us in capital planning, like myself, but then also others who look more after the data, the reliability planning. We kind of saw that need. We saw that a lot of the projects going forward were very big and not really meeting our needs. So we took it on ourselves internally to update our risk models so that we can better evaluate projects. And we wanted to do that so we can communicate changes on our projects. We're trying to transition to doing more smaller targeted projects, because if you do a whole facility replacement, there's some components that still have life, so you're kind of throwing away money if you're replacing stuff early. So we just saw with the pressures that we just wanted a better tool so we can communicate to senior leadership some of these changes to doing more targeted work.
Great. Blair has a question at the front of the room.
Did you utilize the priorities when kicking off projects or when costs came in higher than expected? So for example, at Ontario Northland, we're fortunate when I worked in finance that we built in an inflationary factor. However, because it wasn't based on priority, when whoever had time to do their RFPs first, if they were over budget, it would be allocated to them. And then other groups who had more other tasks on their plate, when they finally got to their projects, even though they probably were more higher priority, there wasn't always enough there. So then they had to kind of recalibrate.
That's a great question, Blair. Let me, yeah, so we actually have that same challenge. Costing is really tricky on the capital side. What we find is that we get an estimate from a design, and then once it goes to tender, it's 1.5 times that cost. Generally, the closer the term, the more accurate. So when we prioritize this year, 2025, these are generally pretty good costs, but we treat everything further out as kind of placeholders. They are costs from design reports, as well as fudging the numbers a little bit to track in like overhead and things that might not be included. When we do get time to do the projects and things cost more, we might re-rationalize that year. We might look at rescoping it. So yeah, we do have those discussions as that year comes up.
Great, thanks. Question, Blaine has a question.
Perfect. Jordan, this is a really profound insight that I think you've been able to build, especially considering your current state. So I'd be curious to know how, when you're dealing with, say politicians, senior leadership, finance departments, people that aren't in this domain, how has the conversation gone with them since then? So, you're bringing these insights, this analysis to them. How receptive are they, and what does that conversation look like?
We're still quite early on in this journey, so we're still working on getting a lot of the buy-in, but so far we've positioned ourselves well. Like throughout the year, we've had meetings with the different teams like operations, maintenance, planning, finance, engineering, and kind of at management level on those teams and even director level. So we do communicate what we're doing, and generally those other departments within our organization like what we're doing. Finance likes it because it's very defensible, and we're linking in with them. It really, everyone likes to be a part of it. So kind of I think it's going well. This budget cycle coming up for next year, I guess we'll truly see how those impacts work. But I can't really say much more than that because this is still fairly new to us.
Yes, I have a question concerning the triple bottom line. Yeah. So recently, where I'm province with the regional district of Nanaimo. Recently, we developed a capital business case template, right, where each division has to put in their capital business cases for the next 5 years, right, with different criteria that we evaluate as the asset management team. One of those, well, 3 of those criteria fall within the triple bottom line, but we still do it very subjectively. It seems like you are scoring those as a consequence of failure. So have you defined the criteria and documented those criteria so they are not subjective, so that you're able to rate them, score them, etc.? And do they carry the same weightage, like the 3 different criteria?
Yeah, thank you for that. Yeah, so to answer your question, yeah, we do business cases, and there's always that some subjective element, but what we have is, I don't have it in my slide deck, but we do have a scoring key. So for that extent variable, if it's a social extent, we would say if it affects 1 to 10 people, you get a 1, 10 to 100, and it's kind of continuous, so if it's 5 people, it might be 1.3. So we have a key for all of these. We weight these criteria. We do it by a monetary equivalent. So we look at if we have the most significant health and safety risk, which could be a loss of life, we look at a dollar value. I believe it's about 10 million, but then we also look at what's the monetary value of the most significant spill. And that's kind of how we weight it, is how significant the different categories are. So generally, the social and financial are weighted a bit heavier.
Great, thanks, Jordan. Question over here. Go ahead.
My name is Henry Adaragofor from Revisions. Great presentation, Jordan. Just have a question regarding some critical assets that you have. So imagine you have some critical assets that are critical versus, for example, I want to understand how you determine the end of life for such critical assets so that you can include their capital spend in the financial planning. And if, for example, at the end of life, when you need to replace that vessel, if you don't have the funding for any reason, and you want to push it forward, what mitigations do you typically consider putting in place to make sure that you reduce or mitigate the risk?
The end of life is tricky. So within our statistical model, we do define an estimated useful life. We're currently doing projects to kind of re-examine them. So we would say that, we look at a pump would be 30 years. We look at the material of a pipe, it might be 70 years, 80 years. Those values, I think, need some work, and we're kind of in the process of looking at them. But the way we look at end of life is we say, okay, we know that estimated useful life value, but we look at a statistical curve and say, as it gets beyond the useful life, that probability goes up. We're doing a project now to calibrate this curve, so we're still trying to figure out how steep is that curve. Is 100% failure at twice the life or 1.5 the life? It's really quite a big project because we're looking at different types of assets that have different kinds of failures. So I guess the short answer is that we're still working on that.
It's great. We have time for one more question.
Hi, Jordan. It's Paul from the City of Camrose here. Lots to think about for me going back and talk to my utility. Anyways, is there any capacity in your water plants and your wastewater plants to have periodic shutdowns and outages to do further inspections of your mechanical equipment and other things to maybe lengthen that lifespan and have a bit more of a better visual of your critical equipment, as you would say, before replacing? Maybe some things you can do to make sure you can increase the life of that piece of equipment. Is there any capacity in the water plants, the systems, that you can do that?
Thank you. Our treatment plants have a lot of redundancy. We're regulated by the Safe Water Drinking Act. We always have to provide water, so we do have a lot of redundancies. Like if we look at filters, we would have multiple of them, so we can take one offline and we'd have enough capacity with the others. So we do that, and we do sometimes look at bypass pumping. So yeah, we can do kind of those targeted shutdowns because we have redundancy.
I'm seeing a head nod, we're out of time. That was great, Jordan. And Niagara Region, the rest of the team, great presentation and great work. Thank you very much. Another round of applause.
Thank you, everyone.
Yeah, that was excellent. If you haven't filled out got your scan for your training hours, please do so as you leave the room. There is a link in the app to do some feedback on the presentation, so please do that as well. And enjoy your break.